Hello students, so today we will continue with exercise 4.2 question 11. Okay, first one, you have to prove this determinant to be equal to this. Okay, so if you want a plus b plus c, okay, if I add this a minus b minus c and 2b plus 2c, then I'll get a plus b plus c, right? So I can take here operation on r1 plus r2 plus r3. Okay, so adding these three rows, you will get here a plus b plus c. So I'll directly write here outside a plus b plus c, that is taking a plus b plus c outside from row 1. Okay, okay, now if you look at the columns, okay, so if I add this and this column, you will get b minus c minus a plus 2b, right? So you will get here, if you add, you will get plus 2b 3b. Yeah, if you subtract, then what you will get? B minus c minus a minus 2b. Then you will get minus b minus c minus a, right? So you can take out minus sign outside, so you will get a plus b plus c. So operating on c2 and c3, that is c2 minus c1, and operating on c3, that is c3 minus c1. Okay, so we'll get 1 minus 1 0 0. Here you get minus a plus b plus c, then 2b minus 2b 0, 2c minus 2c 0, and here again a plus b plus c. Okay, now taking out a plus b plus c from c2 and a plus b plus c from c3, so you'll get here a plus b plus c cube. Okay, then you have to expand. So expanding along r1, you will get here minus 1 into minus 1, that is 1. So the final answer will be a plus b plus c the whole cube. Okay, second sub question. Okay, here also you have to take out x plus y plus z, but here if you add r1 plus r2 plus r3, you will get here 2z, right? So if you add c1 plus c2 plus c3, you will get 2 times x, 2 times y, and 2 times z, so that you can take out x plus y plus z. Okay, so operating on c1, that is c1 plus c2 plus c3, so I'll directly write outside this, okay, x plus y plus z, and inside I'll get 1 1 1. Okay, now I want to take out x plus y plus z, right? So now I can operate on rows. So if you take row 2 and row 1, what you will get? Y plus z plus 2x minus x, you will get x plus y plus z. Okay, so operating along c1 plus C2 plus C3, we got this. Now operating along R2 and R3. Okay, so R2 I can write it as R2 minus R1 and R3 as R3 minus R1. So you'll get here 1 0 0 y plus z plus 2x minus x, you'll get x plus y plus z, x minus x 0, this is also 0, and here it will be x plus y plus z. So taking out x plus y plus z from R2 and x plus y plus z from R3. So you'll get 2x plus y plus z cube. Okay. Now expanding along C1, you will get 1 into 1. So the final answer is 2 times x plus y plus z the whole cube. Okay. Next question is question 12. Okay, so we have to prove this determinant equal to this. Now we want to take out 1 minus x cube from this. Okay, if you expand 1 minus x cube, you will get it as 1 plus x square into 1 minus x. Okay, that is your 1 minus x cube. So looking at the elements here, if you add this r1 plus r2 plus r3, you will get 1 plus x square, right? So I'll write here operating along r1 3. Okay, I'll directly take out 1 plus x square, okay, from r1. So you'll get 1 x square x, 1 1 x square, 1 x 1. Okay, now we want 1 minus x cube. Okay, so no, 1 minus x cube is your 1 plus x square into 1 minus x. So we want 1 minus x, right? So you can operate along C. So C2 minus C1, C2 minus C1, you will get 1 minus 1 0, and then C3 minus C1. Okay, so operating along C2, C2 minus C1 and C3 minus C1. So you'll get x square x, 1 minus 1 0, 1 minus x square and x square minus x. Then this is also 0, x minus x square and 1 minus x. Okay, so if you take out here x common, what you will get? 1 x 1 minus x, right? And here also if you take out x common, okay, this is 1 minus x, so here you will have to take out minus x common, so you will get 1 minus x. Okay, so you can take out 1 minus x from this column. And if you want to take out from here 1 minus x, then 1 minus x square can be written as, so I'll write again. Okay, So this is a plus b, a minus b formula, and here I am writing minus 1 minus x, then 0, x, 1 minus x, and 1 minus x. Okay, so now you can take out 1 minus x from C2 and 1 minus x from C3. So you'll get 1 plus x square, 1 minus x and 1 minus x. So 1 x square x, 0, 1 plus x minus x, 0, x, 1. Okay, so this together will give you 1 minus x cube, and this is 1 minus x, so you'll get 1 minus x cube the whole square. And expanding along R1, you'll get 1 plus x into 1 minus this should be 1, right? No, this is right. So this is 1 minus plus x square. Okay, here we made a mistake. This is 1 minus x cube and this is 1 minus x. So this together will give you 1 minus x cube, and that is our 1 minus x cube the whole square. Okay, let's solve question 14. Okay, so we have to prove this determinant equal to this. So first see that can you take out something common. So from first row you can take out a common, from second row you can take out b, and from third you can take out c. So taking out a, b, c common, you will get, if you are taking a common here, you will get you have to divide by a, right? Now operating along R2 and R3, let's see what we get. R3 minus R1 and R2 minus R1. I'll get R2 minus R1, so 1 by A, 1 by A. Then 1 by B, B minus B 0, C minus C 0, and 1 by C. So it will be minus this is also minus. Now taking out common a from, that is 1 by a from C1, 1 by b from C2 and 1 by c from C3. So ABC upon ABC you will get. So 1 by a I am taking out common from here. So you will get that is, if you multiply this you will get a square plus 1 by a, right? So a square plus 1 will be inside. Then here minus 1, then this will be b square 1 0 c square 0 1. Okay, so now we can expand along any row or any column. So if I expand along, say, R3, let's see what we get. Plus minus 1 0 minus c square, then plus minus plus a square plus 1 plus b square. Okay, so you'll get here 1 plus a square plus b square plus c square. That is the required answer. Okay.